Let's go back the other way. First of all, if it's to a linear function, it's nice and easy. Because you remember when we were differentiating, it was a linear function. All we did was put the coefficient of x out the front. Or if you like, multiplied by coefficient of x. So if I want to go back the other way, I'll just divide by the coefficient of x. That's great if it's a linear function, but obviously there's a lot more things than just linear functions. So in general, we want to try and create that situation where we have the derivative times e to the function x. If we've got that, then we know it'll go back to e to the function x. So we need to make sure we've got the derivative in front there. So if I see e to the 5x, well, that's a linear function. So that's fine. I can go 1/5 e to the 5x. I could still do it the other way and say, oh, e to the 5x, I really would like it as the derivative times e to the 5x. Well, the derivative is 5e to the 5x, but then I have to balance the question out. So I put a fifth out the front, and then the integral of 5e to the 5x, well, it's in the form derivative times e to the function x, so it will go to e to the 5x. So you could still use the other idea, but I think you can appreciate if it's a linear function, it's a lot quicker to just say, oh, it's 1 divided by the coefficient of x, and bang, you've got the answer. X e to the x squared. Okay, it's almost there, but of course the derivative of x squared is 2x, not x. So let's make it 2x, and then we'll put a half out the front to balance it out. We know then that the integral of 2x e to the x squared will just go to e to the x squared, so my answer is a half e to the x squared. Now, at a 2-unit level and a 3-unit level, the exponentials that you end up integrating are all of the form where, hey, the coefficient of the e to the power of something will always be a situation where you're going to have like some multiple of the derivative out the front. In extension 2, we'll see techniques later on how we handle it if it's other ways, if we can't set it up that way. But at this stage, all we need, oh, well, linear function, this one, I'm doing it the other way, you notice, for some insane reason. So I've made it 9e to the 9x minus 5, balance it up, a ninth out the front. So we get a ninth e to the 9x minus 5, plus, of course, our constant. Don't forget our constants. The square root of e to the x. Okay, I've got to put it into index form first, so it's actually e to the half x, or x on 2. That is a linear function, so I could just go 2, but did I? Oh yeah, went the long way again. Okay, so I would like a half e to the x on 2. Balance it out, I need 2 out the front. So it goes 2e to the x on 2, but again, you'll notice I've just ended up with the reciprocal of the coefficient of x there. 2 is out the front. And I've just turned it back into third form because that's how they ask the question, so I'll give the answer that way. Going to have to expand out. We don't have a product rule for integration, so if we expand the whole thing out, then they're all linear functions. There's no way I would have gone the long way for this one, would I? No. Okay, so they're all linear functions in the powers there, so we get a half e to the 2x minus 2e to the x minus 3x plus, of course, a constant. Again, quotient rule. Well, once again, no rule for that, so let's tidy it up. So we end up with e to the 3x minus e to the minus x. Linear functions again. So I get a third e to the 3x. Very careful with your signs here, because the negative becomes negative, negative, which is a positive. So we get plus e to the negative x plus a constant. Let's do a definite one. Not linear, so I would like 3x squared out the front. So let's balance it out. So it'll be a third of e to the x cubed. Substitute in the 1, well 1 cubes 1. Substitute in the 0, 0 cubes 0. So it's just e minus 1, a third of e minus 1. Well, what happens if the base is not e? You'll recall when we talked about differentiating, we said, do it exactly the same, but multiply by the natural log of the base. So logic says when we're integrating, do it exactly the same, but divide by the natural log of the base. So 3 to the power of x would be 3 to the power of x, but divided by the natural log of the base. So log 3 on the bottom there, plus a constant. All right, that'll do us for today.